Hello, Wolves. This is Grade 6 Math, Chapter 2.1, Negative Numbers. Let's get started. This chapter has two main ideas and objectives. The first is to use negative numbers to represent real-world quantities. The second main idea is to represent, compare, and order positive and negative numbers on a number line. Let's look at our first example. Let's begin by thinking about the four different main real-world examples in which you see positive and negative numbers used. The first, and the one you're most likely most familiar with, is in temperature readings. So positive and negative numbers can be used to represent temperature readings that are above and below zero, as shown on this chart. On this chart, you can see that we use a negative sign before our negative numbers to indicate that our number is negative. You do not need to put a positive sign before positive numbers. The positive sign is implied. Anytime you see a number with no sign before it, you can just assume that it's a positive number. However, a negative number will always have a negative sign in front of it so that you know it is a negative quantity. The second situation in which you'll see negative and positive numbers used in real-world situations is to show gains and losses. For example, in a football game, the number -15 might be used to represent a loss of 15 yards, whereas a +30 might be used to represent a gain of 30 yards. The third example is that positive and negative numbers can be used to represent values that are above and below a certain value, such as elevations or below sea level. Sea level is considered to be at an elevation of 0 feet. So, for example, a depression that is 52 feet below sea level would be represented as -52 feet, or 52 feet below sea level. And a mountain that is 7,310 feet tall would be written in this way so that you could see that it's representing a positive value. The final example I'll give for using positive and negative numbers in real-world situations is that you can use positives and negatives to represent debits or credits. So a debit is an amount that someone owes, and a credit is an amount owed back to someone. For example, if you recorded in your checkbook -$180, that would either show you owed it to someone or you paid that out. You took it out of your account. Or a positive number of $79 would mean someone owes that to you, or you added that money into your account. Now that we've seen these examples, let's move on to working some problems. All right, folks, please give these guided practice problems a try. In the first four problems that you see written in red, please write a positive or a negative number to represent each situation. After you finish those four questions, please move on to the green chart that you will use to answer questions 5 through 9. Press pause and I'll be here waiting with the next idea when you finish. Just like positive numbers, negative numbers can also be represented on a number line. So let me show you a number line that includes negative numbers. So here we're going to represent -5 through 5 on a number line. So we'll start with 0, 1, 2, 3, 4, and 5. And here we'll add -1, -2, -3, -4, and -5. So we can see on our horizontal number line, as you move to the right, your numbers increase in value. -4 is greater than -5, and -3 is greater than -4. And as you move to the left, your number values decrease so that we know 1 is less than 2, -2 is less than -1. On a horizontal number line, positive numbers will always be to the right of 0, and negative numbers will always be to the left. We can also use a vertical number line to represent both positive and negative numbers. Here's a vertical number line representing the same set as our previous horizontal number line. So on a vertical number line, you'll see that all positive numbers are above 0, and our negative numbers are below 0. Counting away by one step. So -1 is 1 below 0, -2 is 1 below that. Please note that for every positive number, there's a corresponding negative number. For example, Positive 3 is 3 steps away from 0. Negative 3 is also 3 steps away from 0, just in the opposite direction. These numbers are called corresponding numbers. On a number line, since both 3 and negative 3 are the same distance from 0, we can say that they are the opposite as well. Please note as well that the only number that does not have an opposite is 0. 0 is neither a positive nor a negative number. It is its own opposite. 0 stands alone. All right, now work with some number lines on your own. For problem 10, please copy this absolutely beautiful number line. Fill in the blanks for me in your homework notebook. And for number 11 and 12, create a horizontal number line that includes every single one of these numbers in each set. So in number 11, you have to create a number line that includes everything from negative 8 up to 7, not just those numbers, but everything in the appropriate intervals as well. Same for number 12. Create a number line for me that includes numbers from negative 16 through negative 25. Press pause. I'll be here when you're done. And before we move on to our next idea, Mr. Giraffe says, please write the opposite of each of these numbers. So what is the opposite number of negative 14 and so on? Please record these in your homework notebook. When you get back, we're going to look at statements of inequality. Now we're going to use our number line, which includes positive and negative numbers, to write statements of inequality. Remember, whenever we're looking at a number line, numbers to the left of other numbers are of a lesser value, and numbers to the right of other numbers are of a greater value. You need to be really careful when you're comparing positive and negative numbers because the signs can get tricky. You have to think about where things are located on the number line instead of just looking at the numbers themselves. In our first example, let's solve negative 12 compared to negative 10. Well, negative 12 is to the left of negative 10 on the number line. Therefore, negative 12 must be less than negative 10. Let's try another. Our next pair of numbers is negative 6 and negative 9. Here's negative 6, and here's negative 9. Negative 6 is to the right of negative 9, therefore it must be greater than. Our next pair is negative 8 and negative 5. Here's negative 8, here's negative 5. Negative 8 is to the left of negative 5, therefore it must be less than. One final example. Write statements of inequalities to solve these 6 problems in your homework notebook. Mr. Giraffe says try it. He's confident you can do it. All right, folks, we've reached the final new idea for Chapter 2.1, and that's to interpret and explain statements of order for positive and negative numbers in real-world situations. So the table below, I know it's a little hard to see, apologies, shows the lowest recorded temperature in Alaska for each month from July through December. So we can write statements of comparison for these temperatures using inequalities. So for example, September's lowest recorded temperature is negative 13, and that's lower than August's recorded temperature, which is 8. So we could compare those two temperatures using a statement of inequality where we would say negative 13 degrees Fahrenheit is less than 8 degrees Fahrenheit. Here's another example. This table shows the elevations of some natural features. The elevation of Death Valley, which is negative 282 feet, is greater than the elevation of Lake Asal, which is negative 509 feet. So if we wanted to compare those two inequalities, we would write that as negative 282 feet is greater than, negative 509 feet. Now, if we look at the elevation of Lake Asal, which is negative 509 feet, it's less than the elevation of Driscoll Mountain by quite a lot, which is 535 feet. So if we wanted to compare those two elevations, we'd write it as negative 509 feet is less than 535 feet. All right? All right, folks, these are your last 4 guided practice problems for this lesson. In problems 25 and 26, please write a statement of inequality using a greater than or less than sign to describe the relationship between the pairs of numbers. In problems 27 and 28, please write a word statement, a word sentence that describes the relationship you're seeing in each of these inequalities. I'll see you tomorrow to learn more about negative numbers together in the classroom. Have a great night.